Secondary control for field engineers. How to expand construction survey control. So in this video, I'm going to talk to you about secondary control and the proper ways of bringing it in from primary so that we have it right on the project site. I love this because if we get this wrong, your grid lines will be wrong. You'll be chasing a 1/4 inch, 3/4 of an inch, 3/8 around the building. It will be a nightmare. So let me talk to you about this right now. We've already talked about how every building will have probably a basis of bearings, and then what you can do is create primary control points around the building that are permanent, surround the job site, and are the basis for all other survey shots on the project. Now let's say that this is your slab on grade and foundations. I'm just drawing it that way to make it easy. And of course, everybody knows you have grid lines, typically in the United States at 30-foot intervals. It can be lots of different things, but it should match from drawing set to drawing set. And you want to lay out this building. Thankfully, you have a primary control network where you have a northing, an easting, and an elevation. Okay, so that's awesome. Let me tell you the different types of secondary control. And I'll tell you my most favorite. Sometimes you'll have offsets for a secondary control network. And this is probably the most used, meaning a surveyor will come out and do offsets from the corners. I hate this. This is the most worthless thing ever. And it's because you can't check if a point is wrong. It's very much not helpful to maintain control. It will help you set up batter boards with your sticks and strings, but it's not very useful in the long run. You'll have to trust me on that. The other thing is, I have seen secondary control networks end up basically being offsets on a grid pattern all the way around. I like this just fine. I think this is fantastic, and I'll tell you why. It has corner hinge points, so you can check the perpendicular of the lines, and you have more than 4 points to a line. Let me explain why that's so important right now. This is all from Wes Crawford, by the way. If you have 3 points and they're not in a perfect line and they're not matching for distance, which one is wrong? Well, this could be the line, that could be the line, that could be the line. You don't really know. But if you have 4 points and it's like, this is what's going on, and you notice that this one is off, well, these are all on their increment and they're all in line. Those are the right ones and that one is wrong. So in a 4-point line, you can always find out if a point is wrong because you can compare them within themselves. And so a baseline must have 4 points to it. So that's what, again, why I don't like this. You can check 90, you can check the line, you can check every point. Here, you can't check anything. You can't hit those points and they better be right from the start. So I really don't like that one. The other thing you can do, which I really love, is you can do a single baseline and then turn 90s. It's not as good as if you have the situation, let me draw this one, where you have 2 outside intersecting baselines. That's a little bit better. My favorite, believe it or not, is inside intersecting baselines. And here's what I mean by that. A lot of times, most of the activity and damage is going to be outside of the building footprint. And so if you sleeve the slab on grade for key monuments, or all of them, I don't care, and you are controlling the building from within, where there's a lot less traffic, logistics, generators, pump trucks, cranes, blah, 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 rebar. I freaking hate rebar everywhere. Or at least me when I was a field engineer, I could keep this baseline protected and center all of my accurate control at the cores where it mattered most. I love intersecting inside baselines. So you can design your secondary control however you want. I would say this is definitely a no for me. I hate that the industry does this. And I would say this is probably the least effective. So I'll just write a not super happy face here. And then I'll write a happy face on these because these are the jam. These are absolutely fantastic. This just proves that most of what we do in construction, just because we've always done it, doesn't mean that it's right. Most of what we do is wrong in construction. That's absolutely horrible thought process there. So if we create a baseline and we're like, hey, we want to design this. So let's say we design that in AutoCAD and we want to bring it in from primary control. This is how we'll do it. I have a beautiful traverse that's very precise. I will set up on one point. Let's say I set up here and I'm going to backsite longer than my foresight. That's a rule. And so I'll set up and I'll backsite and I'll lay out this point and this point. Okay, I'll usually want to do it from 3 sides of a traverse. So I did it here, I'll probably want to do it here, and I'll probably want to do it here. I'll show you why in a minute. Then I will go ahead and set up backside farther than my foresight, and I'll lay out, and I will lay out. And then I'll set up here, backside longer than my foresight, and I will lay out, and I will lay out. Now when you look at this monument, if you do this right, we'll end up with 3 beautiful little dots. Now why are they not the same point? It's because of instrumental error. You can say human, but it's mostly instrumental. In a total station, unless you buy those really fancy $50,000 ones, you're going to have about 3/16 of error, roughly around 0.015 of error inside the EDM, the laser inside the total station. And so what you're seeing is that the real point is the average of those 3. And so when I mark my point, I'll mark the middle. See how beautiful that is? Now, here's the key point. When I'm setting up my secondary, I don't want to lay these out from my primary. I'll just go from here to here, and then I'll verify a couple things. That my distance between the points is accurate. What I'll do is I'll mark a line forward, mark a line back, and I will then shoot a distance forward on these, and then set up over here and shoot a distance on these back. So let me actually bring that out a little bit more clear. Let's say I have a point here and a point here. I will set up backside, and I will pound a hub and mark a line, mark a line, mark a line, and then I will shoot a distance and shoot a distance and shoot a distance. Then I'll set up here and backside here, confirm the line, and then shoot a distance and shoot a distance and shoot a distance. If I zoom into this, it will look exactly like this. It'll show, here's my hub, and here's my line, and I'll see a line and a line. Why did that happen? That's the instrumental error again. The point is right in the middle. And so what I can do is mark the middle of these points, and then I'll check it with a tape measure, and you'll be hitting flat. You're not going to be chasing 3/4 of an inch or a 1/2 of an inch or a 1/4 of an inch or 3/8 or an 1/8. You're not going to be chasing that around your grid system. You're going to have a perfect solid baseline here. And if you wanted to do these other patterns, you would simply do the same thing on those other patterns. And then also, like for this one, you could check the diagonal. But the bottom line is that's how you're going to bring it in from your primary control. Your secondary control should allow you to set up and backside along the baseline and have the radius be longer than any foresight, and you should just be able to turn 90s into that building. And that is secondary control. It's building specific and it's semi-permanent. So this is clearly outlined as well with different options in the book Construction Surveying and Layout, and I will turn this into a blog post, and it will become a chapter in Elevating Construction Field Engineers. But the bottom line is, I really hope that you've enjoyed this content. Reach out if you need help. On we go.